let's crank it. Turn it off. Yeah, it's working. In this video, pretty much everything you need to know how to rewire old worn out ignition switch on Vermeer BC1000XL wood chipper. This is 2001 year model. Well, we'll show you how I do it. Without further ado, let's get started. First, before starting pulling the old one out, let's see what's wrong with the original one. It still works. We have a missing key, and the ignition switch contact plates are pretty worn out. It's all loosey-goosey, and is a key. You only can use flat screwdriver or, as we have here, chainsaw bar wrench. It starts, and yeah, let's see if our clutch is off. Okay, we're off. First position, you can hear the solenoid. Now let's crank it. Yeah, chipper fired right up. We have Cummins diesel under the hood. Okay, let's turn it off. Yeah, as you can see, it's working, but problem is it doesn't work all the time. Sometimes it works, sometimes it doesn't. So part, I have a Colin Hersey ignition switch, part number 9579. Came with the 2 keys and all stay here. All mounting hardware, which is in the box, our locking nut, washer, and screws. As you can, our main tool today will be this simple test light. You really need it, especially if you don't have wiring diagram. Even if you have a wiring diagram, always double check your wiring circuit. I already found the wires, I already checked everything. I wrote a simple basic schematic. We have constant 12 volts, we have a starter, and we have ignition switched power to the fuel solenoid, to our feed forward reverse actuator, yeah, and so on. Pretty straightforward. Before start probing wires, make sure your equipment works. Let's go and check. My test light works, but before probing anything, rule of thumb, test your equipment. I'm connecting one end of the test light alligator clip to the battery ground, and if I will find the power, my test light will lit. As you can see, light up. Yeah, my testing tool is working. Now we can proceed and start probing wires. Not a big of a deal. Before probing the wires, let's take a look on the back side of the new ignition switch. We have a BAT, which stands for battery. Battery means constant 12 volts coming to this pin. Then we have a next one, ST, which stands for starter. This pin will get hot only when you put a key in a starter loaded spring position. When you're cranking, juice will get sent to the starter relay and then to the starter solenoid. Okay, then we have IGN, which means ignition. In our situation, it will power fuel relay, fuel shutoff supply solenoid, and also everything what runs when the key is in on position, or feed rollers, actuator, and so on. And ACC means accessory. This is a first position. This one we're not using, but in certain situations when you have to wire glow plug relay or cooling fan or some lights, that can be wired to this pin when you turn the key counterclockwise. Yeah. All right, that's what it is. Pretty straightforward. Let's get to our old worn out switch. Find a good known ground. There's no rust, no paint. As you can see, the stud is here. I'll connect my alligator clip to this ground. And let's go and find our constant battery 12 volts. As I already did. See this blue wire, 12 volts. This blue guy is 12 volts. Let me touch it. And you see my test light is lit. This one's always hot. No matter what, it stays hot. All right? We know where our wire is coming from. As you can see here, and this is all a little bit messy. It's a 2001 year model. It's 25 years old machine. Lots of wiring, rewiring, and repairs were done here. This blue wire goes back and connects to actually this supposed to be white wire, which is hot all the time. Here we go. No, one wire we already found. Let's go to the next one. Is our ignition switched power, which powers the fuel solenoid and our forward reverse. Yeah, all this ignition switched parts. Okay, we have red and light blue, those two wires. This one is going to the fuel shut off solenoid. Ignition is off. Touching the stud over here with my test light. No power. Then I'm turning key to the first on position, and we have power on the ignition, 12 volts switched power. Yeah, as you can see, second stud identified, which is good. All right, let's get to the starter wire. Usually it's way at the center. This one, it's white. Okay, let's now test this wire. Put my test light to it. Nothing. As soon as I crank it, it will fire it up, and you will see the light. See? Only powered at the start cranking position. Do one more time. Watch the test light. Here we go. So those three studs we identify. There's a one more which is vacant. It's on the back, you can see. It's not in use. This is our accessories stud. We'll keep it vacant as we have nothing to connect to it. Yeah, okay. Our wires are identified. We know the studs, what it's for. As you can see, there's a slightly different design on this switch. We have a starter contact is on the side. On this switch is right at the top. This is a Vermeer original switch, which we're going to replace. The all mechanical part of the repair. Have to give ourselves a little bit more slack on the harness. See, it's all pretty tight. Just give us a little bit more room to work on it. Yeah, we'll reorganize everything after we're done. Yeah, just cut this bungee cord. Remember, this wire connects to the stud, 12 volts constant power. Avoid this stud touching the ground, otherwise you will get shorted out circuit, or just go and disconnect the battery. I'm not going to do that. I'm okay. I'm very careful when I'm working on electrical circuits, and yeah, that way I still can probe if I need, but yeah, can go and disconnect the negative terminal. It's up to you. This video is only for demonstration how I do it, what works for me. 100% safe. Make sure you won't accidentally cause a short power to ground, especially on that 12-volt constant battery power to the switch. Just go and disconnect your battery negative terminal, the battery negative cable, put it aside far away from the stud. Make sure you won't accidentally get back and touch the battery. Okay, I'm going to start pulling the switch out. Adjustable wrench, aka crescent wrench, to help. Just make a couple turns to break this nut loose, and then we can pull the switch out. It's a little bit more overcomplicated than it should. As you can see, the ignition switch is sitting behind this module bracket. Actually, this is a brain of the chipper, the computer, called the control module, and it's just right behind. There's one and two bolts I have to remove. Pull the module away and get the switch out. Let's do that. Really, as you can see, I ended up pulling the entire control panel out because I couldn't get to the bottom bolt and get the module a little bit out of the way. As you can see, it's a Vermeer auto feed controller. Yeah, this looks like a old school from early 2000s. Yeah, it's a classic now. Okay, I have my switch out. Now we have much easier access to those wires. I'm going to reconnect wires in order we already know to the new switch, and we should be all set. Yeah, well, it should be easy. And then pulling the switch out, looks like. I'm going to start transferring wires with a starter wire, then we'll do the ignition switch. This one we're skipping, and the last one will be the battery power. That way you won't accidentally touch the ground with the power wire and cause the short. Okay, let's undo this. Stop. Alright. Guys, if you first time to the channel, click that subscribe button. Thank you so much for doing that. Here we go. This is our first wire, and it's going to starter like so. No rush. Take your time. As you can see, everything's nice and clean. No rust. No any moisture intrusion happen. Stubby Phillips screwdriver. Let's just tighten up this wire. There you go, nice and tight. Beautiful. Okay, number 2. Our ignition switched components. As you can see, over here we have 2 wires, fuel shutoff solenoid, and our feeder. Okay, let's remove this guy. By the way, this stud is turning inside the switch a little bit. That's not good. It means poor connection on contact plates will increase the resistance, and you won't have enough current to operate your fuel supply solenoid, and that can lead to the fuel starvation when you are the high fuel demand under the load. That's another thing to keep in mind, that increased resistance reduce the current flow. Okay, there's a nut I'm going to save, and this guy is hot. We're keeping it away. Sure won't touch anything. We're all safe. Okay, we have two more put together. All right, solenoid and the feeder. Okay, get your screw ready. Put them through the eye. There we go. Keep them together. Oh, and verify your stud. Ignition, beautiful. Let's get it started. Place the turn. Rigid wires not cooperating. We have to line up with screwdriver. Oh, come on, be nice. That red wire is so stiff. Doesn't want to line up properly. But have to be patient and push it harder. Okay. Make sure your screw starts straight, not cross-threading. It can happen if you're not paying attention, and then you will damage the threads in your switch. Okay. What you can do after that, I have to put a bolt or re-threaded. Okay, beautiful. Connected. Larger ears underneath, smaller than top. Now we have our hot guy. Yes, this one's hot, and we're transferring him to our constant hot. This battery, as you can see, let me zoom in. Here we go. Battery. All the way. Starter. Storage and battery here. Yeah. Okay, we're not reusing any existing hardware. We're just using a new one, which came with a switch. Okay, this guy is hot. If you disconnected the battery, it won't be hot. Okay, I'll just put it here. And then tied it up. Oh. Alignment is everything, especially when you do electrical and try to thread those tiny little screws. Here we go. Cream and butter. Nice. Don't rush. Nothing takes longer than same job you have to do twice. Okay. I'm pushing on a crimp like that, just holding and tighten the screw. If I will just keep tightening it, this wire will start turning, and then it will cause bend in the eye, or you can even bend the ear. Okay, everything is connected. Nice. Okay, let's see what we have. We have our starter wire to the starter stud. We have our fuel solenoid and feed roller actuator connected to ignition switch power, and we have our battery. Okay. Before putting everything back together, let's see how it's working. See, there's a neutral 0 position where the key will come out, like so. See there, you can hear the relay clicking. Well, let's crank it. Turn it off. Yeah, it's working. You could hear the sound. Let's do one more time. Turn it off. Okay, keys out, neutral position. This is for accessories, which is vacant, we're not having anything connected. And counterclockwise, neutral, key out, key in. First position, we have a power to the solenoid, our feeder rollers, and cranking. Right here, engine is running. Turn it off, pull the key out. Well, fun part is over. Now I have to place this switch in its permanent position, reorganize a little bit this messy wiring, secure it, put this panel back, and guys, if you have any comments, questions, critics, suggestions, recommendations, put everything down in the comment section below under the video. Yeah. One tip: make sure orientation of the switch is following the printed diagram on a panel, then people who will be using the chipper won't get confused. What I found, if I place the switch properly, there's hot 12-volt wire, always hot. I decided to wrap the electrical wire. All right, final test. Chipper is warmed up. Let's fire it up again. We just put a new ignition switch. Make sure our controls are working, forward, reverse, and we can actually chip before machine will get back to work. Chipper is hot. Beautiful. Okay, got a new switch. Well, everything's working. Tested, reliable, good. Now, shouldn't be any problems with this switch for quite a long time. This is already 25 years old machine. Beautiful, reliable, functional, cheaper. Well, that's it for today. And take care, everybody. And we'll see you next one. Bye. Close the hopper. Good enough. Oh, that one's open too. I'm going to close this guy.